Okay, so this is Blender Human version 1. I thought I might share this to everyone. There's still a lot more work to do it, um, but this is physically correct. So this is based off of the human anatomy. So this rig correlates to the anatomy of the human body. So what I mean by that is a normal rig, they just have a single bone, for example, just a single bone for the head. But in all actuality, in order to get the proper movement of how the head actually moves of just this joint right here, it took 4 different bones. And I'll just show it real quick. So if I do rotate Y, as you can see it's going to the side. So it's just hovering over here, but then there's a connection over here. And so when I rotate the other way, same thing happens. And also, if you see how it's kind of curved a little bit, the reason why it's like that is so that way we can rotate our head like that. Another thing, which makes this different from a normal rig, is the jaws. Usually the jaw just has a single bone. But in all actuality, how the human body works is we have this bone right here, and it kind of glides right here. So just doing this rotation, as you can see, it's moving the jaw to the side. And we can also do this way. And by having both of them out, then extends the jaw. Furthermore, if we rotate this, now it's rotating off of this pivot. So it is a really complicated joint right here as well. But a normal rig, what ends up happening is you just have a bone, you kind of just move it forward, move it to the side. It's not actually based off of the skull. And each one of these, the spine, is physically correct. The way that the spine works is there's actually like this little ball that it just rotates on. And so as you can see, it's rotating based off of that. And all the bones are correct. Next up are the shoulders. So the shoulders are fascinating because the shoulder blades back here, they don't rotate. And what I mean by that is we could just see they just glide across the ribs. So if we move it up, then it goes up. And then I created the diaphragm. Rotate X. So this is how people breathe. Then I have the other shoulder right here. And I have inverse kinematics, so I can just move around the hand. And here's the wrist. So the wrist is interesting because, here, rotate. Oops, here, just rotate. Is what's happening is this bone right here is twisting. So there's actually muscle right here that's pulling it. And that twisting motion twists the wrist. And then we have our actual wrist right here. As you can see, it just kind of glides in between these pivots. And I have the hands as well right here. Then I have the body. Inverse schematics, so we can just move this around. And something to note that's interesting is we have this little bone. It's just kind of like hovering. So it actually moves. It actually moves with the knee. And the reason being is the ligaments to make sure it's smooth. And last but not least, the foot. So the foot, you can kind of think of it as a locking mechanism. So if we go here, and I'm not sure if you can kind of see it, but it almost looks like a lock. I mean, it's solid. And when we rotate it, as you can see, now it's locking over here. So it's pivoting off of those bones. If we do rotate, and now it's pivoting over here. But look at that. So it locks. And there you go. So it's locking right there. Now this is an advanced foot rig. And what that means is if I rotate X, it actually pivots off of the toes. And then if I rotate X again, now it's pivoting off the heel. And I want this step further, it can actually pivot based off of the side of the foot. Same thing over here.